Hello and good morning to you people out there. Welcome back to our tutorial series building a Kubernetes Cloud Controller Manager from scratch. This is part 3, and today we will, I guess, finish our implementation of the Cloud Controller Manager. To quickly recap what we have been doing the last 2 streams. Stream Deck is still broken. Gotta find the right scene and switch. Yep. A Cloud Controller Manager in Kubernetes is responsible for exposing some of the cloud providers' APIs in a Kubernetes native way. It has a couple of controllers where the functionality is actually implemented, starting with the node controller, which tries to link the Kubernetes node object with your cloud provider API. Then it annotates and labels the node object with cloud-specific information, like the topology, labels or region and zone, and the instance type, if you need to distribute specific workloads to specific nodes, then that's usually helpful to have. It gets all the nodes' network addresses and makes them available in the status of the node object. And actually part of the node lifecycle controller is verifying the node's health. So it checks if the node is shut down in the cloud provider or even deleted, and then tells Kubernetes about this to either migrate pods off of the node or even delete the node object from your cluster. So you won't have like hundreds and hundreds of nodes in your Kubernetes cluster that are all already deleted. The second controller is the root controller, which we're going to implement today. So we're going to talk about that a little bit later. And then we have the service controller, which watches service objects in Kubernetes that have the type load balancer set. And then it will create cloud load balancers for this and configures the ports and also the server targets that the traffic will be sent to. This is usually used for setting up an ingress for the cluster and similar. Okay, so yeah, we implemented the service and the node parts in our CCM from scratch, and we also have a development environment based on Terraform, where we create a number of resources in the Hetzner cloud. So we create a network, subnet, one server for the control plane, and then a bunch of servers for the workers. So we can test adding and removing nodes from the cluster. And then we use k8s up to actually initialize and install k8s, which is like a very small Kubernetes distribution. And once that's done, we join the workers using k8s up join. And then we also install Cilium as the CNI and a secret with a token for the Hetzner Cloud API, so our controller can work with that. We then use Scaffold to build an image, upload to Docker Hub right now, and install the Helm chart that we also wrote, so our controller runs in the cluster. You can find all the code in the GitHub repository that I'm gonna link in chat if you wanna go into the depths of the code that we wrote the last 2 times. But I'm also gonna write up some blog posts around this topic. So if you are patient and you can wait a few weeks, you get to read it all in a more well laid out manner instead of the ad hoc messiness I'm producing here on stream. One small disclaimer: I work for the Hetzner Cloud, and this is actually working time. So take everything I say about Hetzner Cloud with a grain of salt, considering that I'm being paid by them. And we are using them as an example. You can use any cloud provider you want It's just the one that I'm most familiar with, and yeah, we get employee credits, so it's cheaper for me to use it. Okay, as I mentioned before, today we want to work on the root controller. So let's check out the root controller. The root controller is responsible for configuring routes in the cloud appropriately so that containers on different nodes in your Kubernetes cluster can communicate with each other. Depending on the cloud provider, the root controller might also allocate blocks of IP addresses for the pod network. In reality, let's quickly check out a Kubernetes cluster. Okay, so this is my private Kubernetes cluster, also running on Headstand Cloud. And if we check out the node objects, here we can see that every node has a pod CIDR, which in my case, for the whole cluster, everything is under 10.244/16. And every node gets a /24 for the pods running on there. So this is 10.244.5. And if we check out all the pods running on that node, this is all the pods running on that node, we can see that most of them are in that pod CIDR range. So they have an IP from the range. And in Kubernetes, it is essential that all pods can reach each other under these virtual IPs. So if I would go into one of these pods, I could just ping another IP or access the pods exposed by that pod, and it would be available, as long as you don't have a firewall network blocking solution running in your cluster. There are also some other pods here that have the private IP of the node in the network. These are running in the host network. Specifically in this case, this is networking functionality. So the Cilium operator and Cilium are part of our container network interface solution. kubeproxy is also responsible for routing traffic. And then we have the kubeprometheus stack node exporter, which also needs to access the node. So they aren't running in the Kubernetes network, native network, but on the host. So we don't need to take care of them. Okay, so what this routes controller does is, I should have prepared this tab. Let's check out some projects here. Okay, so this is the project hosting my Kubernetes cluster. And here we have the networks tab. And we see that all these nodes are part of it. We can see that we have the node that we just took a look at in k8s here with the IP that we saw for the host networks. And then we also have a tab called routes. And in our case, if you configure a route for a destination CIDR, all packets sent to that destination CIDR are sent to the gateway. So what we can see here, that all packets sent to our CIDR for the node are actually sent to the node. And from there, the CNI will take over those packets and send them to the right container on the node. Yeah, so that's what we want to achieve today. This is running the official Headstand Cloud Controller Manager for Kubernetes, and there this feature is already implemented. And now we want to go in and also implement this for our CCM from scratch that we've been building the last few days. So let's close up these things and initialize our development environment. I tore it down after the last stream to save some money. So let's run Terraform apply. And this will show us a plan of all the things Terraform wants to do. And it wants to create a bunch of resources and export the kubeconfig for us, or rather show us the string to export the kubeconfig so we can use the cluster. Let's allow Terraform to do this. This is going to take a moment. Oh, we also need to make some changes to the cluster, actually. Let me think. What do we need to do? What do we need? Let's abort this. Okay, usually the CNI is responsible for making sure this is configured. But we don't want the CNI, in our case Cilium, to do this anymore. We now want to take this responsibility from Cilium and implement it ourselves. For that to work, we need to tell Cilium about this. We do this by setting some values in the Helm chart that we installed here in Terraform. Or if you use the CLI, you can set, for example, you can set some values through Helm upgrade install. If you use Flags to install your Helm charts, you have some option to set it there. I'm just gonna copy the flags that we need from our official Cloud Controller Manager, because in here we also have a dev environment. This one based on shell instead of Terraform to keep the dependencies a little bit smaller. And here we can see that we have two additional flags. Tunnel equals disabled, because Cilium doesn't need to set up any tunnels anymore. This is now handled by the private network, as well as the IPv4 native routing CIDR, setting it equal to our cluster CIDR, which we have configured someplace else. Okay, so in Terraform, in the Helm release resource, we have these set blocks, and you always provide the name and the value. So the name for the first argument would be tunnel, and the name of the second one, please don't interfere with my writing. Is this not the way you make comments in Terraform? Oh, it's complaining because it's missing the value. Okay, so the value would be disabled. And then we have another one where the name is equal to, let's just copy that one, IPv4 native routing CIDR, and the value should equal the cluster CIDR that we have configured here on our control plane. Okay, let's move this to a local, perhaps. So that would be cluster CIDR. And then we can reuse it down here. Local.cluster CIDR. And also use it here. Okay. That should be it. Let's apply our changes. This is looking good. Let's check the Helm chart, and it successfully put in the right CIDR here. So let's apply this. And while that's running, let's check out what we need to do code-wise. As we've done in the last times, the main entry point, okay, so we use the Kubernetes Cloud Provider library, and it actually talks to Kubernetes. So we don't need to actually talk to Kubernetes. We just implement the Cloud Provider interface, this interface from Cloud Provider cloud.go. And this is, again, just a wrapper around other interfaces. So it has a method-defined routes, and that returns something implementing the routes interface and a Boolean. The Boolean is whether or not we implement this, and the interface is the actual functionality. So let's check out that interface, and it has only 3 methods: list routes, create route, delete route. Sounds simple enough, right? So this is what we need to implement today to make the routing work. Let's go into the cloud.go and start implementing this. Let's create a new file for this, routes.go, matching the interface we are going to implement. We are going to be in package CCM. We will have a new struct called routes. It will take a client, which is equivalent to which is of type hcloud client, using the hcloud.go library. This also matches our other two controllers that we have set up, and we are also going to need the network ID, so we know which network we need to add the routes to. Then we can use some IDE magic here and just say routes generate implement methods for the I guess that would be should just be routes, and then we can select which routes it actually is, and it's routes in Kubernetes IO cloud provider cloud.go. So that has been imported. How did we name this import in other places? We didn't? Okay. Okay, and then now that we actually implement the interface, even though we just panic, we can start to return this from our routes method here. So let's instantiate a new routes struct and fill the fields. Client is c.client and network ID is c.network ID. And then we can return true instead of false because we actually implement the interface. And then we had an error while setting up the Kubernetes cluster. Creating the secret didn't work. Okay, let's just try once more. Maybe there was some race condition. Because the Helm release and everything else was applied. Yes, I know what the issue is. The issue is that the provider that we use here, we encountered this last time too, the Terraform provider Kubernetes reads the Kubernetes path at startup, and the cluster behind that address, or rather the file in my file system at startup, doesn't equal the file that we have here. Actually, can we optimize this? We could make this something like do we have the local provider installed already? Yes. So maybe there is something like a local file. Maybe make it a data local file, local sensitive file. Sweet config. Let's check out the documentation for this. So right now, this is just a string, and Terraform thinks that the value at the string is up to date, but this is actually only being written after the server has finished execution. So we go in there and we wait for cloud init, and then we locally run k8s up, and that writes out the kube config. So if we use a local sensitive file and we say it depends on our hcloud server control plane, and then we could use the result from that file in the provider. And then I hope Terraform realizes that it needs to wait for this data resource to become available, that needs to wait on the server, and only then it can initialize the providers here. Not sure if this actually works like that, but I just hope it does. No, we don't want to generate, we want to use the data source, reads a file that contains sensitive data from the local file system. Okay, so we have the file name. And that's just equal to local kubeconfig path. And then what does it export? Content base 64, and probably also a file name. So what does the Helm provider take in its configuration? So we could use a path, what we've done before. Okay, so we can't specify the full string instead of the path, but what we can try is to just use the exported file name. And let's hope that it is only exported once we ran this here. Let's use the same for the Kubernetes provider. And let's see whether that works. So let's run Terraform destroy again. I know it's a waste of time to recreate the infrastructure again and again. Also money, because we are billed by the hour, and now we pay for 1 hour even though we only used the server for 5 minutes. But it should be cheap enough to still be okay. Okay, let's say Terraform apply. And we see that still everything will be applied. And also the file will be read during the apply. We did see in here that while we have the local sensitive file SSH, we didn't yet see the local sensitive file data source. So as far as I can tell, this works as expected with regards to the dependency. Control plane has finished cloud init, and now it has finished writing the kubeconfig. And yeah, now we see that it reads the kubeconfig. And also that the creation of the token worked. Very nice. Very nice. Actually, we can optimize this a bit more now, because we have the dependency on the kubeconfig file, which already has a dependency on the control plane. Through the providers here, we can actually remove the explicit depends on for the Helm release and the secret. And this feels like a very nice refactoring already. Okay, now we have a running Kubernetes cluster on 2 nodes. So let's... Thanks, terminal. Let's try to access the nodes. kubectl get nodes. That looks very nice. Let's get the YAML. And we're going to see that the while they have a pod CIDR, they actually still have the cloud provider uninitialized taint, and also the labels that I talked about earlier are still missing. This happens because we aren't yet running the cluster, the Cloud Controller Manager. So let's actually deploy that. We are just going to run scaffold dev, and this will start a hot reloading loop that rebuilds the image and restarts the container whenever we make a change. During this project, I started experimenting with Ko, which is like a very nice Golang, which is like a very nice Go container builder. It doesn't really require Docker or anything else, and it just builds a very minimal container image for all the platforms that you need in a single command. So it didn't really need any configuration. We don't have a Docker file or anything. It just needs to be pointed at the context and the main.go, which we don't need to because we use the default of this directory and this directory /main.go, and then it will build the image. Usually you have to like fiddle around. Let's check out the Cloud Controller Manager. Here you need to fiddle around with what source image you need, what other dependencies do you want to have in your image, and also for using it for debugging, you need to set some specific Go build flags to make this available, and optimize your layers of the Docker file so you only get the minimal resulting image. And Ko abstracts all of that, and in tandem with Scaffold, it's very easy to use. We just say image is from Ko, and everything else is handled. Okay, let's see about our deployed container. We got a bunch of messages here, and we get an error starting node root controller, error running controllers, invalid CIDR nil, invalid CIDR address. And this happens because we did not specify. We actually need to check out go run, and we use the / help command. We also need to tell the Cloud Controller Manager about the CIDR that it needs to manage. Otherwise, it would start to delete routes or add routes that aren't really part of its scope during the cleanup. So let's tell it which CIDR it needs to manage. That's the cluster CIDR flag. Let's add that to our Helm chart, and we are just going to use the same as we have used here. So 10.244/16. And then we use this in the deployment and just specify a new flag here. Cluster CIDR. Was it cluster CIDR? Let's not specify the wrong one. Cluster CIDR, yeah. So that should equal values.cluster CIDR. Okay, let's redeploy this. So scaffold def again. It actually realized that it already built the image for this. No need to rebuild it. And now it tried to set up the routes controller, but actually we panicked, or rather the IDE provided default implementation of the routes. Have a panic implement me, And that's what we stumbled upon. So let's try to implement it. We see that we first try to call list routes. So let's check out the documentation for the interface. What we need to do here: list routes lists all managed routes that belong to the specified cluster name. Okay. We don't really know about the cluster name, but what we do know is the network that we are in. So let's just return those routes in the network. Let's check out the type of struct that we need to return, the root. It has a name. It's the name of the routing rule in the cloud provider. It will be ignored in a create. Target node is the node name of the target instance. Enable node addresses is a feature gate for target node addresses. At false, ignore target node addresses. Okay. Without this, if users haven't updated their cloud provider reconcile, will delete and recreate the same route every time. Are the node IPs? Destination CIDR is the CIDR format IP range that this routing rule applies to. And then black hole is set to true if this is a black hole route. The node controller will delete the route if this is in the managed range. Okay, so in case you delete a server, then we can mark it as black hole, and the node controller will instruct us to delete that route. Okay, so let's get the list of routes that we have. We are going to use the client that we were passed, and here we have the network client where we have a okay, so we don't have a list routes, but we have a get call, get by ID actually, and here we can pass in the network ID of the current network that we're looking at, that we were configured with. Maybe let's check out where this is coming from. So when we create the routes struct, we pass it the network ID from the cloud provider. And this happens when we initialize the new the cloud provider. Then we read that from an environment variable, hcloud network. This environment variable can come from anywhere, but in our case, similar to the hcloud token, we just read it from a secret called hcloud, and there we have the token and the network keys. Yeah, and that's how you configure the network ID. This happens automatically in our development environment, because in our secret that we create, we have the token and the network data fields set. So they are being made available from Terraform into our Kubernetes cluster for use by our CCM. Okay, so we get that by ID, and we get back the network, response, and error. So let's check out the network. We don't really need the response, and we need an error. And if error, is there an... Yes. If error is not equal nil, return a nil error. Otherwise, we need to also check, let's check if the error is error code not found. We don't return an error, we just return a nil network. So if network is nil, we return an error. Return nil format.errorf. Let's copy what we did with the other. We probably don't do that there, because we don't need to explicitly check for the network. So let's say network not found, network with ID not found. And then pass it the network ID. Okay. Now we have the network, and here we have the list of routes. And we can map these. So we kind of need to go from these routes. Let's check out how they look like. Network route. They have a destination and a gateway. So they are basically exactly equal to what we see in the table in the Cloud Console. So the routes have a destination and a gateway and nothing else. There is no server associated with the gateway or anything. We need to figure this out by ourselves. But luckily, we also get back the list of servers in the network. And every one of those has a oh, I thought it would have the private IP. Does the network not have the list of assignments? Like which server is in there and what is its IP? Curious. Okay, we can still figure it out. It's just gonna take a little bit more code to do that. Okay, so we want to list the routes. So let's set up a routes slice of the return type cloud provider route. Actually, let's make one, and we can already say that it should have 0 entries at the start, but the total length should be equal to network.routes, because for every route that we have in the network, we are going to return one element. And then we are going to iterate through the routes in our network, network.routes, in range network.routes. And we're going to create a new route of type pointer to cloud provider route. And we're going to append that to routes, append and assign route. And at the end of all of this, we're going to return the routes and no error. Okay, now we just need to figure out how to map the hcloud route to the route. Okay, so let's fill in all the fields so we know what we need to provide. We already can set up the destination CIDR, because that's just hcloud_route.destination is the IP net, and we can convert that to a string, and that should be the destination CIDR. I don't think we really need the node addresses. Let's read up on that perhaps for a moment. Is a feature gate for target node addresses. Let's research that. Target node addresses. Okay, so it just passes the node status addresses in there. And then we could create different routes for multiple addresses, right? So in case you have like a IPv4, IPv6 dual stack cluster, then you could create routes for both settings. But in Hetzner Cloud, private networks are IPv4 only, so we don't really need to take care of this. And I guess false is the default here, so we can, let's close some of the tabs, please. False is the default, so we can get rid of these two. So we only have the name and the target node left. And the name, routes don't really have a name here, so we can also just use a made-up name. So let's use just the two identifiers of the route. So we have the destination and we have the gateway. And that will be our name. So we only need to figure out the target node and whether a target node actually exists here. Can we return it's the name of the routing rule in the cloud provider? We might actually get away with returning 0. Let's check out where it's used. Okay, so it's being logged. So let's keep it in. So the logs are a little bit more helpful in case something happens with it, but doesn't seem like there's any other usage of the name. So we don't need to be overly cautious setting this to a sensible value. Target node name. Okay, I don't know how we should handle if there is no node for it, but I guess we can just not set the field, aka return an empty string and set black hole to true in that case. Okay, so we need to find the node for this. Because we have the gateway IP, we just need to find out which server is that gateway IP. And for that, we can find out, we can iterate through all the servers in the network. So for server in range network.servers. And then because we don't know which IP this server has in this private network, we can iterate through the private nets of the server. So for server network in range private net, and server network has the IP as well as the network. So we got to check if the network ID equals the one that we're looking at, so r.network ID, or rather if it doesn't, if it doesn't equal, then we're just gonna continue with the next one. If it does, we check if the server network dot IP equals the IP that we were given here. So hcloudroot.gateway. And if it does, yoo-hoo, we got our target node. The thing is, in this case, we want to abort the search immediately. So let's say that we got the target node variable here. Our target node is a server. So hcloud.server. And then we set target node equals server. And now let's make that a new function. Extract method function. Get target node, find target node. And what we want to do is we pass it the network. We don't really need to pass it the routes. We can just pass it the... Oh yeah, we don't even need to do that because we have the network. We can just use network.id. Then we have the root is the gateway. We could instead pass in the gateway IP. So that becomes the gateway. Gateway IP, net.ip. And then we also don't need to pass in the target node because this is just what we return. So hcloud.server. And then we return the target node or return the server. Okay, so we either find the server or we don't. So let's say that we got the target node. Let's initialize the root above that. Let's remove the target node and the black hole parameters. And then we can say if target node equals nil. If we don't find the target node, then we can say root.blackhole is true because we don't have a target for it. And otherwise, we can say that root.targetNode, the node name equals targetNode.name. Okay, it needs to be a node name instead. Yeah. Okay, and the default is kubelet will use hostname as the node name. Okay. Very nice. So that basically should be the functionality of the list roots. We can get rid of that parameter because we don't use it. And yeah, I guess we can test it. Our scaffold setup was happily building and restarting the container all the time in the background. Let's see what the logs say and where it crashes now. Still pushing the image here. Now it's deploying. Okay. Hello? Okay. Couldn't reconcile node roots, error listing roots, get lookup API headstar.cloud.io timeout. Okay, we had a similar issue last time. Yeah, let's not use the k8s in here. Let's go to k8s in Golang is kind of slow for me. So let's use it outside of that. Okay, so core DNS isn't starting because core DNS expects cloud provider to be initialized. That doesn't make any sense to me. Oh yeah, we forgot something. Actually, because we are now kind of acting as a CNI, we also need to run in the host network. So we need to say in our deployment host network true, so we don't rely on the Kubernetes network, but on the host network. Let's see if that fixes stuff. I think we need to restart it. It doesn't really detect changes to the Helm chart. Okay, so it has a problem, couldn't reconcile node roots, error listing networks, but at least we synced the nodes successfully. So why can't it access the network? Oops, let's say context active hcloud context use CCM from scratch hcloud network list 3339462. That is the right ID. So why can't it list this? Actually, let's check out what request it makes. We set up wrong cloud.go. We set up the cloud provider to accept a debug variable called hcloud debug, and then it will write all the logs to std error regarding the HTTP requests that hcloud.go makes. So let's introduce another variable here. Debug by default, it's false. And in the deployment, if values.debug, then we add another variable called hcloud debug with a value of true. Otherwise we don't do anything. Okay, and then in scaffold, we are gonna set values debug equal to true. Let's see whether that worked. Scaffold def. And then in the deployment, we should see here, yeah, that there is an environment variable called hcloud debug. Okay, and here we see the pull requests being made. In this case for the server, another one for the server, and the network. Okay, so we did get back a network, but we still returned an error, network not found. Oh yeah, if network equals nil, then we want to return the error. Well. That was an easy fix once we actually knew what was happening. We could have also put a debugger here. Scaffold actually supports this very nicely. You just run it with scaffold debug, and then it will open a port for the debugger. Okay, so now we are crashing again with a panic implement me. This time in the create root method. So let's try to implement this. So we got the context, the cluster name, the name hint, and the root. We don't really care for the cluster name. We don't really care for the name hint. We only care for the root that we want to create. So again, let's take a look at the root. Name, target node, destination CIDR, and black hole. In this case, we actually could use the target node addresses. Anyway, let's use the target node. Again, we will need the we will need to get the network. So let's wrap that in a function. Refactor extract method. Let's put it on the roots here, and let's call it get network. And in this case, we don't really need this. We only need the network and the error. Okay. And then in here, we get the network. Okay. So the only thing that getNetwork does is it changes the semantics of getById to also return an error if there is no network. GetNetworks is the semantics of ID to also return an error if no network was found. Okay. So we get the network. Let's go to create root. We want to get the network 2. And then we want to find the target node. Or in this case, this is ugly. Can we make this nicer? Let's actually try to use the node addresses. Enable node addresses true. And see whether that works. So in that case, we wouldn't need the network here. We would just get the node addresses, and then we could find the one that we, the private IP in the node addresses. Okay, so that would be the gateway IP. Var gateway IP match.ip, and then we're going to iterate through the addresses in the target node addresses, and if address.type is not equal to address is not equal to v1 dot okay. I forgot where this is defined. Get node addresses. Yeah, so we want the internal IP of the node. v1.internal IP. If it's not the internal IP, or rather, if it's the IP, we set the gateway IP equal to the address map.parse IP from the address is valid. Is there something like this? What happens if parse IP fails? If valid, we return the IP, and otherwise we return nil. So let's check if gateway IP is unspecified, because a nil okay, if gateway address is nil, then we return unable to parse node address, and then just pass in the address. And otherwise we break the loop, and that's just the value that we want. We should also handle that nothing is returned. Unfortunately, that's the same check, but it's a different error message. No internal node is specified. We don't really have anything to log then. Okay, otherwise we now have the gateway IP, so we can call hcloud dot r.client.network.add_root. Specify the context. What else does it expect? A network pointer. We don't really have the network object, but we could just fake that with the ID that we have, network ID, and just hope that it works. We could get the network prior to this. We could also like cache it on every call to list routes. We could just cache it in our object here, but we don't really need it. We can just specify the ID, because the only thing that it's doing here is that it takes the network ID. Doesn't really use the network in any other way, but of course that's using the internals of hcloud Go in a way that you shouldn't. And the last one is the network at root opts. So let's use that network at root opts, and can we let it fill? Okay, network root hcloud network root fill all fields. So we have the destination and the gateway, and they are net IP and net IP, IPnet and IP. Okay, so the gateway would be gateway IP, and the destination, of course, would be root.destination CIDR. Net.parse CIDR. Let's extract this here. If there is an error, let's say enable recreate root, and just wrap that error. Rather enable to parse destination CIDR. Okay. And then we can use the destination CIDR down here. And we get back an action and a response. And in this case, we probably want to wait for the action to finish, because otherwise the network would be locked anyway, and we couldn't add another route. So let's say that we get the action, the response, and an error back. Again, if we have an error, unable to create route in hcloud, we wrap that error, and then we want to wait for the action. We use r.client.action.watch progress on the act, passing the context of the action, and then we get back a progress channel that we don't need, and a progress channel and error channel. And we're gonna say if error equals to error channel, waiting on the error channel, error not nil, then we return an error again, waiting root action failed, and just return the error. Okay, and if we didn't encounter any errors, we can just return nil here, and that should be it. Let's see for our code. So we had some funny issues here. Let's see. So it tries to delete a root. Where did it get that root from? Why are there roots even set up in the network? Perhaps it ran on a previous iteration of the code. That's the issue with the dev. You never know what is actually being executed right now. Okay, so now it's feeling on the delete root. So let's implement that and then try to figure out what is going wrong here. Okay, so delete root should be even simpler. We again don't really need the context, and for deleting the root, the only thing that we really need, let's check out the client method, network.delete root, passing in the context, the network, and the, what does it expect? Network delete root ops. And it expects a root. What is it using from the root? Again, the destination and the gateway. So we would basically need to do the same as we did here. So let's make a function from this. Refactor extract method function would be Kubernetes root to H cloud root. Don't really need the string, we just get the root. And then this returns the net IP, IPNet and the IP. So the destination CIDR and the gateway IP and a single error. Let's check out if everything makes sense. We parse the CIDR. We don't get a, if there's an error, yeah, okay. Let's remove these from the error messages. Okay, yeah, that sounds good. Let's update our usage. Don't really need an error 2 here. Just have an error, refactor rename error. Yes, continue. Okay, yeah, that sounds good. Let's actually, we could just return the network root instead. So let's say that we don't return these, we return a hcloud.network root, a pointer to an hcloud.network root. And at the end, we return the network root. Nice. Okay, and now with that method, equipped. We can use that in delete root and just say that we want to convert the root to an hcloud root and then delete that. This is annoying. Okay, so delete root runs that and returns the response. Okay, nice. So let's handle that. We got the action, we got the response, and we got an error. If we have an error, same bullshit as always, return format.errorf, unable to delete route, unable to delete route in hcloud, and then wrap the error. Otherwise, we wait for the action. And then we return nil if nothing else happened. Return nil. Nice. Okay. Okay. That should be it, basically, for the root controller. Let's see what scaffold, what the logs say about this. Okay, so we kind of run into an error here. Okay, let's debug this perhaps, and then it can give us some insight. I'm just gonna put a breakpoint on the list roots function, and I'm gonna run scaffold debug. And where is the debugger? Debugger? Where is the debugger? Why is this view so weird? Yeah, I'm just blind. Select debug launcher run config. Okay, again the question, why is this view so weird? Where is our top bar? Or how do I get there? Yeah, if anyone in chat knows, okay, hi Stranos Refinery, this is advertisements on my channel. I don't like that, so I'm just gonna yank your message. How do I do that? Yeah, Okay, perfect. Sorry, got an unnecessary message advertising in my chat. Okay, why is the interface not showing stuff? Settings. No, wrong settings. And right settings. Okay. Appearance and behavior. Why is the main toolbar hidden? Okay, we already know the name, main toolbar. Main menu, show main toolbar. Trigger, please, trigger. Why? I mean, this is the right menu, but I kind of want it to be shown to me in here. Okay, I don't really know what this does, but let's try it. Okay, so I don't know. I don't know. Perhaps this is some Wayland weirdness, but at least our run configuration is here now. So let's export the kubeconfig again. Say scaffold debug, and then click on the little bug icon, and that should start the debugger. Deployment failed. Can't be pulled. Okay. Works now. Okay, so let's put in the debugger again. Okay, so somehow target node returned nil for the root that we have. Let's check out the roots that we actually use right now. So networks and subnet. So we have the 2 and the 3, 2 and the 3. So I would expect them to match up. But we didn't find a target node here. So we set it to black hole true and put it into the list. Okay, so for the second one, let's go into find target node. So we have the gateway IP 10.0.0.3. And what is in? Oh, sorry. Needed to sneeze a little bit. Okay, what is in the server that we have here? Oh, okay. So it's not a full server, it's only a partial server. It doesn't have the private net set, so doing this is invalid. I don't like this. Let's check out because I think the CLI also does this, right? We can say hcloud network describe, and then it shows us. No, it doesn't show us which nodes are in the network. What the fuck? Is there like literally no way? Sorry, that's not a cloud. Is there no way to get the list of member IPs of a network from the network? Hmm. So there shouldn't be anything set in the server. Yeah, it's just the ID of the server and nothing else. I don't like this. This means that we need to get all the servers. Get all the servers. This sucks. Is there anything which we can use to filter these servers? No. List ops names that is sort. Nothing of that will help us. So let's just get all the servers here. Okay, so we list all the servers, and then in find target node, we also need to pass in the servers list. Servers is a slice of server pointers, and then we're going to iterate through these instead of the network. I don't like this. I think I'm going to submit this as feedback to the networks team. Okay, let's stop this and just try running this once more. Scaffold. Okay, so there's still an issue. So I should have just kept debugging. Okay. Okay, the first one, let's jump over it. we get back a successful server. So that should put in the target node name. Target node, let's take a look at it. It's the CCM from scratch control. We are currently setting up the root or listing the root. Why doesn't it show the hcloud root variable? Hello? Could you please show it to me? Okay, but we have the root, and that's the 0 and the 10.002. And our server from scratch has a private net of 2. So that would be the expected result here. For the second server, okay, so we have 2 roots, CCM from scratch. And this one, and they don't have any target node addresses. Okay, so the question is, what is it doing with these? Okay, so it lists all the nodes and then it does a reconcile. So let's take a look into the reconcile here. Okay, it sets up some internal data structure for all of our roots. And then it should have 2 internal roots. This is the wrong one. These are the roots that we passed it. Why are there so many roots set? What? This seems wrong, but okay. Thanks, debugger. Okay, but the root map should have 2 entries with each 1 node and 1 root. Okay, so it writes back the node addresses for the node. And then every pod CIDR is being added to a root action. root map CIDR with action. Okay. So let's check what the pod CIDR is we take a look at right now. So the pod CIDR is this. And I would expect in the root map for this node, there should already be a root that matches this. So there's the destination CIDR and the target node. Or perhaps it's really about those node addresses. We're gonna see. Let's go into get root action. We forgot to step into it. Can I move the cursor back here? No. Okay. Let's see what action it decided upon. CIDR with action. Didn't evaluate. Didn't evaluate yet. What is the action? The action is update. Huh. Okay. Okay, next one. This time we go into get root action to check out what it actually does. So it iterates through all the roots for this node. Checks if the destination CIDR equals our CIDR. It does. And then if... Okay, so it checks the node addresses on the object if we say enable node addresses, but we don't return the node addresses in here. So what we could do, but that doesn't make sense because we don't use the node addresses, so I guess this doesn't make sense for our context. Let's hope that it still writes back the code later. Let's just continue for now. Next iteration. Let's get back into reconcile and let's check out the actions it does now. Did we properly restart this? Let's check out if that is removed. Enable node address is true. No. Let's restart this. Okay, restart doesn't really work. It restarted the process but didn't reattach. And hello to all viewers who recently joined. Nice to see you around here. If you have any question, please feel free to ask me. I can also give you a rundown of what we are doing. If you want, just say hi in the chat. Or don't. Not gonna force you to do anything here. We are currently debugging some fun issues around the roots controller. It's, based on my experience, the one that provides the most pain in this whole thing. I don't even know how many people actually use it the way it's intended to be used, but it's always a source of fun. Okay, let's get out of here, step out, and then get into the reconcile here. Step over into the reconcile. And yeah, let's perhaps put a new breakpoint down here and run till there, and then check out the action it generates. So the action is still update. Enable node addresses true. Okay, so it looks like we still didn't build the updated code. So let's do that once more. Remove the breakpoint here. It's not really useful anymore to us. And start the debugger. That took too long. Let's start the debugger again, and we are at the breakpoint. And let's see what action. We got the keep action. Nice. So now it should work as expected. Okay, let's remove the breakpoint and just keep it running and observe the terminal. Action for node with CIDR keep. Same here. Okay. Looks like it's properly keeping those roots now. Very nice. Very nice. Let's disable the debug logs for now and just run the dev. And then we can try to add and remove some nodes to see whether that does the right things. We can also check out the roots in here in the Cloud Console, and we can see that it properly set up our two roots for the pods. Okay. Yeah, let's add a new node to the cluster. We can just go into the dev environment and say node count is 2. Actually, it should be even one more because we have an additional. This is just the worker count. Can we rename this? Worker count. Did that work? Yes, it did. Nice. Okay. Let's run Terraform apply then. And it adds one more server. It also adds it to the network. This is going to take a moment. Until the node is available. That went successful. Let's check out our logs. And we can see that it's initializing the node. It initialized the node. And then it decided that it wants to add a new action, root spec to be created. Some stuff. We actually can see that it has the node addresses in here, even though we didn't specify the flag. And yeah. It created the root. Okay, let's try to see what happens if we remove the node back in our dev.env Terraform. We're just going to set it back to 1. and run terraform apply. And we're gonna see here that it is deleting the root. Could not delete root. No internal node address specified. Creating root for node. Why did it decide to delete roots? What is happening right now? Let's stop this process and try to find out what was happening. Okay, so it realized action for node with CIDR add. Why? I would assume something removed it from the network. It's back to be created. Okay, I think we can make the deletion easier because right now we rely on the here delete root. We need the root to delete something, which is the destination CIDR and the gateway IP. But we kind of don't need the target node addresses because we can just pick the root that has the right one for the delete. Because the destination is unique, we can use that as the decider which one we want to delete. Now the question would be, do we even need to specify the full root, or would it be enough if we have the destination? Let's check out the docs for this. So network actions, delete a root from network, both are required. Okay. Okay. So we kind of need to figure it out. But we can still optimize it, because if the node is deleted, it shouldn't have any node addresses left, right? So in that case, we can't use k8s root to hcloud root. Instead, we would need to use the Then we need to get the network. Oh, also it's not available in the network. Huh. Okay, I'll tell you what, let's introduce a cache here. Network is an hcloud network, and servers is hcloud servers. This is slice of server. And then these are set r.network equals network, and r.servers equals servers. Actually, let's just move this here. Get network doesn't return the network anymore, but it sets r.network equals network, and then we are gonna rename that refactor rename update network. Yes, please, in all methods references. And then let's do the same for the server. So yeah, for now, let's say refactor extract method with a update servers. And then this should only return the error. And what we should do is add some like locking around access of these caches to do locking. Okay, that's list routes patched up to use the new caches. Let's check out create route. It can now use r.network, and same for delete route, r.network. And then we can I still like to use the node addresses if they are available. So let's try to build a backup in here. If it's not nil, we're just gonna return a value, and otherwise fallback if no internal IP is available. Then let's use the routes here. Actually, let's make all of these pointers so we don't need to copy the data every time. Especially relevant for these two, otherwise they would fail. Okay. So in that case, we want to check the list of servers for the right IP. So let's go through servers for server in range servers. let's say we want if the name equals, but in case, the server is already deleted, we also won't have it in the server's cache. So that wouldn't work either. I'm gonna check out how we did it in the upstream provider, in the actual provider. So in the delete root call, okay, so we just use it from the network. That's actually nice. Okay, thanks, Lucas. So if, let's revert the change we made here. If it's nil, return format.ref. Unable to parse no internal IP set. And otherwise we return this. Okay, but in the delete context, we don't want to use that. Instead, we just iterate through the network. So for roots in r.network.roots, if root.hcloud root I always forget the range here. If hcloud root dot destination is equal, dot string equals root dot destination CIDR, then we have our gateway IP. Okay, we're going to return an error if we don't find the gateway IP, and we set the gateway IP equal to the gateway in our hcloud root, matching the destination CIDR. Would it make sense to implement the fallback down there? Perhaps it does. Yeah, let's do it that way. I'm changing my mind so many times about this code. I'm able to figure out gateway IP, neither node internal IP is set, nor does a matching route exist in Cloud. And at the end, let's return our Cloud network route. Destination is destination CLDR, and gateway IP is our gateway IP. We don't have an error. Okay, so we first try to get it from the internal IP. If that's not available, we try to get it from an existing route, and then we return the error. It's probably not the cleanest way to do that, and there are very probably some edge cases where this fails, but it's enough for our purposes here. Let's try to run it again. Scaffold dev. Cannot use routes. Oh, okay, yeah. We need to make this a pointer to routes. Okay, so it still thinks it needs to add a route. Okay, so the issue was that let's go through the lines here. At first, the Kubernetes API still had a node, so it tried to add the route for us because the route that we returned was probably marked as black hole. Then it realized that it needed to delete the route and that there wouldn't be Okay, good thing is it kind of figured out what it needed to do after a while. But the log messages aren't really confidence inducing. Okay, let's add another node to the cluster. Once more. Yes, please. And see what happens. Okay, it synced successfully. It decided that it needs to add a root. So that case works perfectly. Let's try to remove the node again. Okay, why does it think, okay, let's quickly, because the controller will remove the server if we don't fix this. So we try to trap it and always tell it that the server exists. So it doesn't remove the node object from Kubernetes and we keep running into this case. Then let's put a breakpoint here to see what roots we return. Scaffold debug. Okay, so we have 3 roots. And one of them is a black hole root. So we got the 0, 1, and then 3. Okay, that seems to match with what it should be. Let's get into the reconcile method here again and check out the root map that it builds in its mind. Okay, so the immediate issue is that for the actions it tries to take, it doesn't really take into consideration roots that are marked as black hole, because the root map it builds only has the roots with nodes set. And then it also has another method, should delete root. Okay, so if the root is a black hole root, or it should be updated or removed, then in a go routine, it will remove that root. Updated is true. And then in parallel, it processes the creation of roots. Okay, so this is kind of intended by the way our dependency works. Let's check out the code that we have for the hcloud cloud controller manager here for a second. Just to make sure that I am not doing anything stupid. So delete root. Looks like it would run into the same issue. Just that it probably returns earlier because it tries to find the server from the cache and fails there. And if it fails, it just returns an error and doesn't actually try to create the root. Oh yeah, and it also validates that the root doesn't already exist. Okay, so yeah, it's just some case of dependency illness. Create root. We will check for existing root. Can happen in case server was deleted in API, but still exists in Kubernetes. But node still exists in Kubernetes. Okay. So I think we are finished with the roots for the most part. And let's commit this and push it so you can check it out and improve all the bugs that I introduced. Let's return that to its expected value. Let's go through the methods because I did some refactoring that I later regretted to see if there is something that we can unrefactor. Update server, update networks. That matches what I want to do. Find target node. This is only used here, but it's actually helpful because we got a double loop, and then we can just return it to break the loop instead of having to use a labeled statement that we can then break. Create root, delete root should be as expected. Yeah, okay, nope. Everything sounds fine. Let's check out what we need to add here. Yes, this initializes our new roots client. This is our new roots client. Host network is necessary for the roots. Cluster CIDR needs to be specified. Debug is useful, but can go into another commit. This we want to split up. Sorry, cannot split this chunk. Okay, then let's do that later. No. Yes, we want that. We want this. No. What do we want to commit? We want to commit the changes that are necessary for the routing. So I did the wrong stuff. Yes, all of this, not this one, not this one. We want to split up this. Work account isn't necessary. Cluster CIR is. We want to split up this one again. This will be used. This will be done later. The refactoring of the dependencies in Terraform can be done later. We want to split this one. We want the Cilium changes. Yes, we don't want the refactoring of the dependencies. We don't want this because this is related to the dependencies. Don't want this change. Don't want this one. Okay. Commit feature roots controller. Next, let's do the debug stuff. Oh, this also needs to go into the last commit. So let's add the values file, chart values, git commit command, and then let's put the debug. Yeah, for sure, this one. Let's put the debug back in here. Yes, this one. Yes, this one. Nope. 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 Yes. Feature. Helm. Debug logging for HL go. Yes, and now we can do the refactoring here. We can just restore that file. Don't need the changes anymore. Okay, so that would be feature, or rather fix dependency chain with kubeconfig. Okay, let's push all of that. And we are kind of done with the main Cloud Controller Manager implementation. What I do want to do still is set up a GitHub, some kind of end-to-end testing, where we actually create a cluster and run some tests against that cluster to make sure that it works as we expect it to work. But I'm gonna take a quick break, and I'm gonna be back in 5 minutes, I think, to finish the testing. I just need to update the scene here. What time is it now? It's 12:19, so let's say I'm gonna be back at 12:25. Okay, see you around. And welcome back. I don't know what it is, but every time I go into a break, I really want to get fresh air into the room. But then I think because I start the break so late, I really need to pee, and I just rush to the toilet and I forget to open the door. So the window is still open. I hope it's still okay for you. And I'm just gonna close it after a few minutes, and I hope that it doesn't interfere too much with the screen. Okay, let's get back into the code. I don't know why it's black sometimes. Right, we want to set up some CI validation for this. So let's think about this. We kind of need a script to automatically set up a new cluster, run the tests, and then tear down the cluster again. So let's make a new directory hack. Let's create 3 scripts: CI setup env, CI run end-to-end tests, and the last one is CI setup. What is the antonym to setup? Antonym setup. Break up, dismantle, take apart. Let's call it CI tear down in .shell. Really, setup shell is just Terraform apply oh, actually, we also need to run Terraform init. Terraform apply. What is the flag to automatically approve? Auto approve. And tear down would be Terraform destroy. Auto approve. This is a dangerous script. Yes, please give me shell check. We probably also want some flags in here, some options, just to make sure that the bash environment is fine. Let's use these. Yeah, thank you. Nope. And this one, and also a interpreter shebang, just to make sure that it's running in a reliable, consistent environment. Okay. Now, to run the tests, we can probably just use go test and then do something like test. Oh yeah, it also needs to run export qconfig equals qconfig.yaml. And then in the test, we can just run go test end-to-end, maybe like this. And then we can create a new directory here. Test end-to-end. Not in examples, just in the main directory. Thank you very much. Setup also needs to do scaffold run to build and deploy the image and then stop executing. And actually, let's also do this here so we don't have a dependency between the scripts. Actually, let's just do it at the start here. Okay. And then in the test directory, okay, let's try to run this. So ci set. Okay, this should work. The infrastructure already exists, so it's just going to reuse that. And then it's deploying our CCM to the cluster. Nice. And then in the tests, we actually have to implement some tests for this. So let's do what can we name this? Just like the packages. Func test change removed. T testing T. And for the test cases, we kind of need some additional Kubernetes libraries, right? Can we, with the default Go setup, can you go testing global prepare? Because we kind of want to initialize a Kubernetes, like kubectl Kubernetes client. Okay, so testing, we got a testing main. It is sometimes necessary for a test or benchmark program to do extra setup or teardown before or after it executes. It's also sometimes necessary to control which code runs on the main thread. To support these and other cases, if a test contains a function, then the generated test will call test main instead of running the tests or benchmark directly. Test main runs in the main Go routine and can do whatever setup and teardown is necessary around a call to m.run. m.run will return an exit code that may be passed to OS exit. Test main returns, the test wrapper will pass the result of mrun to OS exit itself. Okay. Is it necessary that these files are named _test? Yes. Okay. Okay, so this automatically happens then. Package et. Then we are gonna need some variables here. And the first one would be a Kubernetes client. Let's check that out. Kubernetes Go client. Client Go. How do I use it? Gonna say go get. And then doesn't tell me how to actually use it though. How do I use it? How do I use it? In out of cluster example. Nice. What did I do? Okay. Let's write a new function. Set up cube client. That probably can return an error. And then in here, we are just gonna use the kubeconfig path, which should be kubeconfig.yaml. Might also be this one. So that gets us a config, and then we want a client set. Is that right? Is there some nicer one? I don't really like this explicit client. I really like what controller manager is doing for the Kubernetes clients. Let's check out package go dev. Let's check out the dynamic client. Okay, so it doesn't really do anything useful for us. Let's just use the client set here then. It's a Kubernetes client set, so let's put the variable here, client kubernetes.client set. And then it should be like this, and that assigns it to the global variable. Nice. In case we get any errors, we just return them. Return error. Return error. And return nil. And then if we get an error here, we can just say m.error. We can't. Okay. Then we just say panic error. Okay. Do we need to parse flags? We could read that from an argument. Actually, we could just read that from os.getEn kubeconfig. Always a little bit surprised that this doesn't work automatically. I know that there is the in-cluster configuration. Nope. Where is the... Did I close the docs for... Yes, I did. So this has the client command subpackage, right? Tools client command. So let's check out that one client command. Default client config loading rules. What are they? Hmm. I'm kind of scared that it would use the main kubeconfig file. So I'm just gonna keep it like it is right now with the explicit get env. Okay. Yeah, let's run this. I'm just gonna run. Actually, I'm just gonna run this through from test signature, fixed signature. Okay. I'm just gonna run this here to see whether it works. Um, hmm. Oh yeah, if I run it through this testing configuration, then it probably wouldn't have the environment variable set. So let's do that. Let's add kubeconfig with value home Julian git documents git ccm from scratch kubeconfig YAML. Let's try again. Okay, it passes. Nice. So it can successfully create the client, probably not make a request. Let's verify that. So we want to eventually okay, let's just try to client core v1.nodes.list. Do we have a context? Do we have like a timeout deadline? Yeah. What does this do? Reports the time at which the test binary will have exceeded the timeout specified. Okay, so let's also put that into the main. Let's define a context that all code can use. Oh, but M doesn't have the timeout. Well, no timeout it is then. Okay, so we're gonna list. What else do we need to provide? Options. What is the shortcut for smart complete? Um, okay, and then this returns the nodes, node list, and error. If error is not nil, t.error. Okay, yeah, there's fail now. Fail now. And that doesn't accept anything. T.error does log and a fail. Ah, okay, so there's fatal. Okay. Okay, so fatal F. Unable to list nodes. Okay, so what we basically want to check is that every node doesn't have the well-known label initialized. So if node dot spec taints, is there some helper function to work around the taints? Now it would be really useful if you knew your way around around the Kubernetes library. But basically we could just iterate through them and check if a specific taint is set. Okay, what taint do we have? We have the uninitialized taint for the cloud provider. Let's check out if that taint is defined somewhere. Yeah, it's in cloud provider API. So the taint we are checking against, expected taint would equal v1.taint. The key would be kubernetes.i would be cloud provider API dot something. Let's import that. Cloud provider API is equal to kubernetes.io slash cloud provider slash API. And then that is taint external cloud provider. What does match taint do? It checks the key and the effect. So what effect is it assigned? Is that perhaps documented in the list of the well-known taints? Yes, no schedule. So if the taint matches expected taint, then we are gonna say t dot error cloud provider taint on node, and then we can pass in the node.main. Okay, let's test this again. And everything passes. Nice. Let's just to make sure that it actually fails, let's check the reverse, and it's also successful. Let's debug this. Okay, so we have a node, it has a spec, and it has taints. Oh yeah, because it doesn't have even a single taint. So we would need to do this here. And then we could run that check. Okay, nice. Okay, I'm not gonna do all the things. I'm just gonna implement one test for each, and then the rest is left as an exercise for the reader. Okay. So the next one would be the load balancer. So let's add a new file, service underscore test.go. Tests will be provisioned. And in this case, I think I'm gonna make it even easier. Just gonna create a pod and a service and verify that it receives traffic. I think that's the simplest thing, or the fullest scale thing we can do. Just gonna quickly close the window here. Just realized that it was still open. Okay. Test service works. For that, we need to create we have an example somewhere, right? Example service load balancer. Okay, so we can create a pod and a service. Let's start with the pod and let's actually wrap it in a deployment. So core v1, no, client dot apps v1 dot deployments. We need to provide a namespace. How are we going to do that? We are just gonna set up a namespace in the testing code that we can clean up afterwards. So set up test namespace. Namespace is a string. So we can use the client core v1 dot namespaces dot create. We can use a new context. Let's just use context too. I really don't know what's the difference between to do and background. Non-nil empty context. Okay, and background. Okay. Okay, so they just have different names. So let's do background. And then it accepts also a namespace object and some create opts. Can you please? Okay. One dot namespace. And then let's rename that to core v1. Guess we don't need the type meter. Probably need the name in here. We need to make up a new name for our namespace. So go random string. I don't need a fast way, I need a simple way. Okay. For sure. String, and then we need a n characters long. Let's just make this 8. There shouldn't be anything happening. So namespace equals format.sprintf ccn end-to-end string, and then the namespace. Okay. This is missing one argument, right? It's missing the create opts. We call v1.create opts. Nope. Meta v1.create options. Try run fieldman, and nope. We don't want any of those, I think. Perhaps let's take a look at the example in the client. This is just a get. Does it perhaps have an example for creating something? Create, update, delete, deployment. Perfect. Okay, so yeah, it works with an empty options. And then we get back the namespace and probably an error. We don't really care about the namespace, but we do care about the error. If error unequal nil, return error. And otherwise return nil. And in the teardown, we are gonna do something similar, and that is client.call v1.namespaces delete context.background and call v1. It just accepts a name, right? And delete options. So the name would be namespace, and anything interesting here? Propagation policy. Would be foreground. To make sure that it's actually deleted during the test case. What is the Kubernetes pointer utility? Pointer.to. Okay. And then again, we probably can get back an error. In this case, we can just return that. Mm. OS exit actually exits, right? Or does it just set, yeah, causes to exit? Sorry for that. Okay. So that should give us a namespace. Can we, is there, no, that's fine. Let's close some of the files that we don't need right now. And then let's say for the deployment, namespace is obviously equal to namespace. And then we would like to create, pass in the context, pass in the deployment. Perhaps v1. Don't need the type meter. The object meter has a name, and that will be service nginx. We don't need the status, but we do need the spec. Replicas is going to be 1. Selector is going to be something. Template, we don't need a strategy. Don't need any of these. I wonder what the default is. Default's to 1, so we don't need that one either. So we only need the selector, the v1 label selector, so that's probably for v1.label selector. No. Apps v1 label selector. Meta v1 label selector. And then it probably needs some meta v1.create objects. Okay, nice. Let's fix some of those errors. What template spec is unresolved? Okay, part of core v1 instead. So the meta, we need to define a label here, labels. Nginx. And the spec, let's get our example here. Should be quite simple. We should have a single container with the single value. Name is Nginx. Image is Nginx stable. And ports. We're gonna have some ports, and there we have the container port 80 and a name equal to HTTP. Oh, let's just call it web. Okay, so that should create the deployment. Let's do the same for a service. Networking v1 dot apps v1 dot service. Okay, we'll explain service. Okay, it's core v1. Again, we don't really need the status and the type meta. Object meta can also be service Nginx. And then we have a spec, which is a service spec. And in this case, we have a type core v1 load balancer. Service type load balancer. We have a selector. App is Nginx. We have a list of ports that we want to expose. Service port name, yeah. Oh yeah, I need to make a struct in here and then just fill all the fields. So that's web protocol is TCP. App protocol doesn't really matter. Port is 80. Target port is web. Where is this int string? From string web, and node port will be automatically set. Okay. Now that we have created those, we basically want to wait for LB to become available and then send test traffic. Okay. Let's check out how such a service looks like. Okay, get service just from my cluster at home. YAML. So it has a status load balancer with a number of ingress IPs. Doesn't really have a ready flag or a condition or anything. Okay, so we could just wait until some ingress IP is available. Let's see. Kubernetes, what utils do we have? Is there something like a retry until? Okay, so the client Go even has a retry helper. So what we need to do is we provide a configuration and then a retryable function. Okay, so let's see. Retry dot on error. Let's make this a global variable because we will need to wait on things more often. So back off. And then our retryable function. That's passed in an error? Okay, so we define two functions. One checks if the error is retryable. We just return true. Let's also move that to a constant. Always retry. Okay, now we can okay, we basically want to get the service. So maybe let's do save the service we get here. So we want to refresh the service. Also service client can be this. Service client. And then we can say service client dot get what? So we don't need the service here. So that would be this service and an error. And in case we have an error, and then in the service, we check if service dot status dot load balancer, and that's probably a pointer, right? Right, okay. So what we are doing is we are gonna retry this function a bunch of times until it doesn't return an error. And in this function, we get the service from Kubernetes and then check if it has any ingress IPs set, and return an error if there aren't any. So we retry again, and nothing if there are. Okay, and lastly, we want to send some test traffic to the endpoints and see if something turns up something. So actually, let's define the service here. So that's a pointer to core v1.service. So we can reuse the service from the last retry to get the endpoints. Don't need to send another request. Okay, so service dot status dot load balancer dot ingress. We kind of want to find out the IP. So we need to figure out if it's an IPv4 or IPv6. We're just gonna take care of the public IPv4. Find public IPv4. How are we gonna do that? We can check what is ingress. Ingress is a ingress.ip is the string. Okay. What does the net package offer for this? IP. Lookup IP, parse IP. How can we figure out if it's an IPv4 or IPv6 address? So 2v24. Okay, so net.parseIP 2.4. If if we can parse the IP and to IP4, if IP not nil, break. No. If it is nil, continue. Else we kind of need to figure out if it's part of the public thingy. Can we, with an IP net, can we check contains? Yes. Yes. So let's create a IP net. Is there something like parse CIDR? Yes. Yes. Is there perhaps something about... Yes, is private. Ha! Perfect. And this probably says that 10.0.0 is a private address space. Okay. So we can say if IP is not nil and IP dot not is private, then we just break because we found our IP. And afterwards we need to check if IP is still nil. Then we need to fatal F, no public IPv4 available. Okay, and now we can send the test traffic. I have never actually sent an HTTP request in Go. So let's check out Go by example and hope that they have an HTTP client example. Perfect. Okay, so we can just say HTTP GET. Way easier than I expected it to be. Let's just copy this code here. Don't really want to take care of the body. Any of this, we just want to check the results. So HTTP GET takes a URL. Okay, so the URL would be printf HTTP our IP, and the IP would be IP.string. And then we can check the response status code. And if it's not okay, then we can also log t.fatalf unexpected status code. That's an integer, so response dot status code. D is for integer, right? Decimal. Okay, and otherwise we are done. Nice. Let's test this. Let's edit the configuration here to run the other one instead. Or rather to run all the tests in our package here. Does it have a name? Name, yes. Go test, okay, that name sounds good. Let's run that, please. And we can put out, we can actually watch the events. So k events A. It's starting a container. Failed to create endpoint for service. It ensured the load balancer and our test. Very nice. Very nice. I don't think I'm gonna do a test for the roots because this is kind of already tested through the other stuff. So let's did it actually clean up the namespace? k8s. Yeah, it did. Nice. Did it clean up the load balancer? Yeah, it did. Perfect. Wonderful. This is working way better than I expected. Okay. Do we still want to do something? Yes, I want to run it again, just to make sure that it wasn't a fluke. We should see a load balancer being created, some targets being added. And tests have passed. And the load balancer should already be deleted. Nice. Nice, nice, nice. Actually kind of a bug that you're still on the load balancer page if it's being deleted in the background. Okay. Yeah. Yeah. I'm happy. Let's add all of this. We need to still write the code to run this. Oh, there. Ah, it's just the mode change. Yes. Someone forgot a new line at the end. Tests for removing ports, removing targets, removing these, question mark. Okay. Yeah, I think that's it. Test setup end-to-end tests. Okay, I got one thing left that I want to do, and that is I want to add that to a GitHub Actions pipeline, just because. So let's create a new directory .github, create workflows, create a file end-to-end.yaml. Let's think about what we want to do here. We want to run it on push, mail, on push, just on all pushes, please. And we have a list of jobs. We have the end-to-end job. We kind of need, okay. What I want to do is I want to use the TPS action. Because I work for k8s Cloud, I have access to our CI system. And I can get free CI pipelines there through a system called TPS, and we have a action that uses this. This doesn't really apply to the tutorial, but it's still useful for me right now. So let's just take the example here. Oops. Okay, so we need to prepare the environment a little bit. Especially we will need to set up Terraform and scaffold. So GitHub Actions setup Terraform. And GitHub Actions setup scaffold. This actually runs scaffold. I only wanted to add that binary to the environment. Okay, how are we doing it for the Cloud Controller Manager? I know that we have some script to automate this. Test end-to-end. Okay, we just use Actions setup cube tools. Question is, do we need anything else? Helm, kubectl helm might be needed. Let's just go with the flow and also use these. Probably won't need them. Let's just use scaffold for now and verify if that works. What version of scaffold do we have? 2.6.3. Let's use the same in CI. And then we have the command run the setup. So ci setup env shell. Then we have run hack ci run end-to-end tests.shell. And lastly, we got run hack ci teardown and shell. And we also want to run that in case there was a previous failure. GitHub actions, workflow syntax. For a job. Nope, for a step. Can we specify continue on error? Prevents a job from when a step fails. So we would need to set that continue on error. True. Tests can still be successful if cleanup fails. But we also want to run that if the test previously failed. So we specify if failure. If, well, we don't only want to use it on failure, we always want to use it. Success, always, okay. Always. Also clean up if tests failed, if setup or tests failed. Nice. Yeah, I think that should be it for the CI pipeline. Let's try to add that. Git add. Because we can't really test that locally, let's create a branch for this. Let's switch create GitHub actions end-to-end. And let's try to push it there and see whether that works. No such file. Oh yeah, because I also need to do a checkout. Of course. Without a checkout, there is no code to run. So that's why I wanted to keep it in a separate branch. Just because I know that writing pipelines is an error-prone process, and yeah, it's nicer if I can just amend that without feeling bad. Okay, so it's failing because it waits for the token, which we didn't properly set up. CI setup env, it will probably be terraform apply help. How can we configure a variable? Okay, so we can say var terraform apply var hcloud token equals hcloud token. Oh, yeah, we were also gonna need that on the teardown script. Abort, please, abort, cancel run. Hello, Titan. Thank you for your Prime sub. Much appreciated. You're just joining now for the final moments of today's stream and also the Cloud Controller Manager implementation. Yeah, today we implemented the roots controller and then some end-to-end tests, and now we are running them in GitHub Actions, and we are just waiting on the results here. Okay, so it failed because it couldn't find k8s up locally. That makes sense. Let's see, it didn't run the tests, but it does run the teardown. Very nice. So yeah, let's set up k8s up. We are already using the action setup cube tools. Let's hope that it also bundles k8s up. k8s up. Where is the list of tools? Okay. How are we doing it in the Cloud Controller Manager? I know I've been saying that many times, but as I thought, okay, we are just running k8s up install. So let's do the same here. Run this. Thank you. Let's add the code and push. And wait for the next pipeline. At this point, I'm obligated to say thank you, Hetzner Cloud, for providing me with the resources to run the end-to-end tests. Much appreciated. It's running the setup. Hey Yoshi, also thank you very much for the subscription. Much appreciated. If you are the Yoshi I know, then welcome to work. I hope you have a nice day at the office today. And we can see that it successfully created the node and is now running k8s up. Very nice. Waiting for the cluster to initialize. Control plane was done. Now creating the first worker and installing Cilium at the same time. We don't really have a way to debug issues if anything happens, because we don't expose the kube config. So let's hope that no problems turn up. And invalid attribute in provider configuration refers to an invalid path. Kubeconfig, no such file. Hmm. How is this complete? Why was this successful? Okay, two issues here, I think. The version of Go that is running in the code is too old. So we need to update that. And then we also need to figure out where we want to push the image to, because we didn't think about that previously. And I think we can just ignore that because the Helm chart was complete and also the secret was complete. So that error doesn't seem too bad. Let's see. So we want set up Go. With the Go version. Users options setup Go at v4 with Go version is 121. Yeah, because the issue is that starting with Go 121, you can actually specify the minimum point release, patch release of Go in the Go mod file, and older versions of Go can't really pass that properly. Okay, and the second one was pushing the image. So how can we tell Scaffold what repository to use? Image repository handling. Default repository, my repo. Okay. And then we could use the GitHub container registry, GitHub actions. Just need to make sure that the image is actually public. It's available with GitHub free. Okay. To authenticate to a GitHub packages registry within a GitHub Actions workflow, you can use GitHub token to publish packages associated with the workflow repository. Okay, so we kind of need to set the source label to our repository and then figure out how to configure the credentials. The credentials for Scaffold. Might need to run a login. I'm not sure. Oh, okay. Scaffold. How do we set the image labels? Okay, let's for a moment just clean up some tabs around here. Okay. Okay, so the source would be just the path to the repository. So that would be replicate CCM from scratch. Nice. Okay. Let's just see how the action maybe handles this. Okay, yeah, it does a login. Okay, let's do that. Pipelines get so complex so quickly. And then we probably also need to amend the permissions here. Permissions. Should set permissions for this access token in the workflow file to grant read access for the content scope and write access for the packages scope. So required for k8s.io contents read packages write. Okay, let's try that. CI fix pushing images. Oh, we also need to set the repository, right? So run end-to-end tests would have, wait, who is setup? Okay, setup would need an env variable called scaffold default repo that is equal to ghcr.io/replicate/ccm from scratch /end-to-end. Let's try this. Let's push again and see if it works now. This never-ending waiting for pipelines in this job is really, really annoying. Waiting for the server to show up. Doop-de-doo. Yeah, the speed could be optimized by first creating the nodes and then running k3s up in a separate step. So we don't wait with creating the second node until the first k3s up is finished. We could just start all nodes at the same time and then run k3s up in the order necessary. But I don't know, that would shave like 20 seconds here. Not relevant for this project, but if you do it every day with a bunch of pipelines, then it quickly adds up. Okay, so it looks like it used the right package here. Curious to see if the push will work. Can I see the packages I have? Packages. Yeah, it's usually quite fast, but in this case it doesn't have any of the caches available, so it still takes a bit of time to download the dependencies and stuff. We could add a cache there, but we could also build the image in parallel with setting up the environment, and then just run it once the cluster is ready. Actually, where can I see the packages that I have? Packages 2. It's not there yet. We could probably configure code to use a cache from the can configure a cache. Question is, can we tell it to use some pre-built images as cache? I don't know. I really don't want to get into optimizing this too much. Okay, so it pushed successfully and it also deployed the deployment to the cluster. Let's wait for the tests to finish now. Also, we should now see a image and it's actually public here. That's good because that means we can pull it. At least I hope so. Okay. Oh boy. It failed because the path for the kubeconfig that we export doesn't match the path where it's running from, because this runs in this directory and the relative path doesn't work. So if we say this is equal to pvd kubeconfig, then that should work. And then we also need to do that in the second file. Here, we don't really need to do that, but that's nice to have. CI fix kubeconfig path. And another run. Another 4 minutes to wait. Okay, so it reuses the Go cache. So it didn't run setup Go. Probably only on success. Because that would cache the actual Go build cache, as far as I know. So hopefully once we have the first successful run, subsequent successful runs are quicker. Oh, what a beautiful day. Yeah, during downtime like this, I really realize that I'm not an entertainer. I don't know what to talk about if I'm not actively working on something here. Okay, what I can do is give you a sneak peek at the blog posts that are coming up. Because, yeah, we are waiting anyway. We can also check this out. Can you just give me the link, please? Preview. Yes, yes, perfect. Yeah, so I'm trying to condense everything we've learned in all the streams so far into a series of blog posts, so no one has to sit through all the 14 hours of content we have done in the stream so far. Yeah, it's also part of the lab days, and I will actually be focusing on this for now. So we don't do any more streams. I was also at the beginning thinking we could do other integrations like a CSI driver or similar, but for now I want to finish the blog post for the Cloud Controller Manager before starting any new projects. So streaming after we finish the pipeline will be paused until I published the blog posts. I don't think writing the posts is actually interesting content. That's why I'm gonna do it out of stream. If you disagree with that, feel free to say so in the chat. Let's see. Okay, so it deployed successfully, and we are now running the tests. Also a new scaffold version. Let's see. Highlight CRD status check. Okay, not a lot of relevant stuff for me. I'm not that deep into scaffold. Okay. Always love to see people highlighting the contributions of Renovate or Dependabot. Okay, looks like the tests were successful. We probably want to run them with the V statement. Are there any other flags? Go help test flag. So the V flag should do some verbose log output, so we print all the text, even if the tests succeed. Usually not that interesting if you're running it locally, but very interesting if you run it in CI, because yeah, always nice to have the full output in CI. So in here we are just gonna add a -v flag, and then we are gonna add that command rebase against main, just fix up everything, and then merge that in main. Git cherrypick end-to-end, git push. Okay, nice. I think that's it. We also saw that it actually cached our build output here. Setup Go, it cached the Go mod and the build cache. Question is, what key does it use? Setup Go. Okay. Not sure what this is, this hash. But that's nice. Very nice. Okay. Yeah, that's it. Let's quickly review what we did today, and then I'm gonna close the stream. Okay, so today we implemented the routes controller, which is responsible for setting up routes in the private network. It takes over some responsibility of the CNI to make sure that pods are accessible to each other. We implemented 3 methods here: list routes, create route, and delete root. We did some debugging around these to figure out why some stuff didn't work. We amended our development environment to make it work a little bit nicer, and also to set the flags on Cilium required for the routing. Then we set up some end-to-end tests. We added scripts to set up the environment in a CI-like way. So Terraform init, Terraform apply, scaffold run, and the teardown, Terraform destroy, and in the middle a script to run the tests. And then in the tests we wrote 2 quick tests. One verifies that we actually initialized the nodes. We do that by checking all the nodes and verifying if the cloud provider label taint was removed. And then we also have a service test which deploys a load balancer, or rather a deployment, and then a service of type load balancer. And then it waits for the service to become available and then sends HTTP requests to verify that the pod actually responds and works. We also wrote some code to make all of this possible. We set up a new Kubernetes client and generate a new namespace and tear down the namespace. Not really necessary in CI use cases where you just create a cluster, run the tests, tear down the cluster. But if you run this locally, then it's nice to have new namespaces for every test run. So you actually get to see, you don't run into conflicts between the namespaces. For example, with the deployment, our deployment here has one name. So if we run that twice in the same namespace, the create call would fail. Okay. Yeah, it's still building. I don't know if it actually... Yeah, cache is not found. Apparently didn't restore any cache. But actually that doesn't really matter because we already verified previously that it was working. Okay. Yeah, of course. Sorry, I was doing the recap and then got distracted because I forgot what I was doing. The last thing we did was set up a GitHub Actions pipeline that installs a bunch of tools, Terraform, Scaffold, k8s up, and Go, and checks out our code. Then we get a token for the Hetzner cloud to run the tests. We log into the registry, then we run Terraform through the script I previously showed. We run the end-to-end tests, and then in any case we tear it down again. Yeah, so that's it. That culminated in a successful pipeline that I can show you right here. As you can see, it's very successful and definitely finished. Definitely finished. My water is empty. I'm really thirsty, but I just want to get through this stream right now. Feels like it has been dragging on for long enough. Still waiting on the service. Ha! Service worked. It's now tearing down the environment again. And that's a success. Nice. So yeah, that's it. Stay tuned. I'm gonna at some point post those blog posts and then you can read up on them. You can also, very nice to announce this at the end of the stream, all the streams are available as VOD on Twitch and YouTube. The stream for the VOD for this stream will only go live on YouTube tomorrow. So yeah, that's it. Thanks for staying with me through the series, and see you around when the next time I'm gonna stream. Goodbye. Where's the new scene? I really need to fix the stream deck. Goodbye.